Hello and welcome to my series Learn Radiology with Dr. Anil Joshi. This has got different lectures over different topic for different speciality of people. Some are for the radiologists, some are for the other specialty of the medicine, some are for technicians, and some are also for common people, and these are in local language, that is Hindi. Now today's lecture is on radiation physics. Now radiation physics, we got two sets of lecture. One is extensive and detailed lecture, and this is a simplified version of same. So here you will get a superficial idea. However, for getting it in depth and correct, you will have to visit my website and go for a detailed lecture. So today's topic is design of X-ray room. At present, a disclosures. Most of the material is from our routine teaching. We have got PG classes, we have got PG students who are elevated from the MBBS degree to the MD degree by giving their different lectures, by different knowledges, and this all material is in the department for many years, which we routinely use. However, if there are some material which has come from the net, is all copyright free. Now let's go to the lecture. Today's lecture is designing of a CT scan suite or room. Here CT scan we have to consider is a radiation producing unit. So all the precautions required for the safety measure, not only for the working staff but also for the surrounding people, needs to be considered, and a room needs to be designed and safety measure has to be according to that. So accordingly we design this room and we'll see the details which are there. Now what are the general guidelines? Comparative room size for different radiation unit is different. Now for X-ray unit, for example, it shall not be less than 18 meters square for general purpose radiography and conventional fluoroscopy equipments. Gantry of CT unit shall not be less than 25 millimeters square. Now only unit which produces radiation of the CT unit is the gantry. So its measurement are more than that of the X-ray. X-ray room is 18 millimeters square, while the CT room is gantry room is 25 meters square. Now note, more than one unit of any type shall be installed in the same room. So not more than one unit shall be installed. That means in gantry room you cannot keep any other radiation producing units. There cannot be another unit which is in the gantry room. For that example, not even in X-ray room, no two radiation producing units can be in same room. That is what the norm is. Now as we have seen, not more than one unit of any type shall be installed in same room, and no single dimension of this X-ray room shall be less than 4 meters square. Now mammography unit room size shall be not less than 10 meters square, and no single dimension of the room shall be less than 3 meters. So these norms has to be kept in mind before designing a room. Now here we are specifically saying a CT room which is producing slightly heavy type of radiation. Now what is the wall thickness? Any radiation equipment located in the residential complex shall be ensured that the wall of the room on which primary X-ray beam falls are not less than 35 centimeter or 14 inch thick, either brick, concrete or their equivalent. Now walls of the X-ray room on which a scattered X-ray falls are not less than 23 centimeter or 9 inches thick, either equivalents of concrete or of the brick. That means where the tube faces for the X-ray, and whether in the gantry you have to find out whether the tube is straight line to it in 360 degrees, the thickness of wall is more. However, once the ray hits and bounces, it becomes a scattered ray, then the requirement of the wall drops slightly less, from 14 inch to 9 inch. So that should be the design of the room. You have to find out an area where the primary beam hits. You will have to find the area where the scatter beam hits, and you design room accordingly. Now there is shielding equivalent to at least 23 centimeter or 9 inch wall thickness brick or 2 mm lead in front of the doors. So doors also need to be protected. Now what we use in the door is the lead sheets, and the thickness should be more than 2 millimeter. The rule applies for the windows also. So windows and rooms of the room are protected properly. Now either by general public or not under possession of owner of the X-ray room. The density of the normal masonry brick is considered as 1.6 gray per cubic centimeter. So that is the equivalent we are seeing which blocks the radiation. In other words, easiest to remember, find out where the primary ray is going, make it 14-inch concrete, find out where the secondary ray is going, there you make it a 9 inches equivalent or thickness, and if the doors are there, you protect them with 2 mm thickness of lead. That will give you a correct room. The ceiling must have a thickness of concrete because people are staying above or below there is a basement. Now thickness of concrete must not be less than 6 inches. Usually it is more than 6 inches thick. So we do not have to worry about the ceilings and the floor because the concrete thickness usually is more than 6 or more than that. Since the room size is more, the concrete also they have to make slightly heavy. So it suffices the criteria. Now what is the options in shielding the material? The radiation equipment must be installed in adequately shielded room to ensure that public in the vicinity are not under exposure to X-ray radiation. Now this comes as a protection of surrounding people, especially if there is a stationary population. Like if there is office, then you have to take more care than a mobile population where the population is moving. But either way, you have to protect them. The adequacy of shielding depends on the material and thickness used for this purpose. Different material can be used for shielding. However, brick or concrete are considered the best material because almost all the construction today are made in these. It is easy, it's economical and have got good structural strength. It should thick walls should hold, should balance the load of the slab, which is also more. Now control room comparatively is not a radiation producing room. Since the equipment is operating at 125 kV or above, there should be a separate control room. This is important. So as we have seen that in radiation producing unit there is nothing else. Similarly, no control and gantry room are same. They are different. Control room is different. Now here we have to consider that rays should not come from the gantry room. So since the equipment is operating at 125 kV or above, there should be a separate control room and should be provided with appropriate shielding. Then a direct viewing window which has got a glass equivalent. That is, there is not a routine glass. It's a glass which has got capacity to hold radiation and is equivalent to 1.5 mm of the lead thickness. Now doors, as we say, doors are lined with 2 mm thick lead sheets with proper overlapping at the joints. There should not be gaps which leaks the radiation, and the walls of the 9-inch thickness or brick and ceiling should be 6 inches of concrete. So in other words, primary radiation 9-inch, secondary 6-inch, concrete above and below 6-inch. Easy to remember. Now viewing window, lead glass of suitable dimension and provided as viewing window with 1.5 mm thick lead equivalent. So it is also should be a protective. Then should be a mobile protective barrier whenever required. Control panel should be behind the mobile protected barrier which has got thickness of 2 mm or equivalent. Here best what we say is have a separate room for the control. Now computer tomography employs a collimated X-ray, that is fan beam, that is intercepted by patient and by the detector array. So both these detector array and patients, they reduce the radiation and subsequently only secondary radiation is incident on the protective barrier. Now the operating potential typically in the range of 80 to 140 kV as the workload are much higher than the general radiography fluoroscopy. Here the patients are more, there are quick turnover of the patients, and the radiation we are using is at the range of 140 kV. So care has to be taken properly, and due to large amount of secondary radiation, floor, wall and ceiling needs to be special consideration. Additionally, scattered and leakage radiation from the X-ray system are not isotropical. Not to worry about it because they have got regulations over them and the manufacturers are very particular that they will be in a safe limit of working. Now the radiation level in the direction of the gantry are much less than the radiation level amongst the axis of the patient table. Now this is the typical room of the CT. We are seeing a X-ray room, a CT room where the gantry, we have shown the table position. Now from console, patient should be seen properly, which is over gantry. So even if patient goes into the gantry, the console room, they can easily view the patient. And if there are any problem with the patient, they are attended. Dimensions, I have already told you. Therefore, we conclude Adequate shielding should be provided for the floor, roof of CT room, depending on which floor the CT scan is located. If it is in between, then above and below, not only sides, needs to be protected. It was proposed an additional thickness of 2.5 mm lead or 162 mm of concrete to shield the front and rear reference points so as to reduce the doors to 1 milligray per year. So this is a maximum radiation that is allowed. The highly collimated X-ray beam in the CT result in markedly non-uniform distribution of absorption dose perpendicular to the tomographic plane during the CT exposure. So they are considered much safer than what we think. They are fairly safe units. Therefore, the size of the CT room housing the gantry of the CT are recommended by AERB not less than 25 meters square. As a radiographer, as a radiologist, not only you have to take care of yourself, not only you have to take care of the patient, but you have to take care of the patients, relatives, and also surrounding neighboring people. For that reason, a CT room has to be designed properly. There has to be proper radiation barriers so that the outside population, patients, relatives will not be exposed to the radiation. With this, I thank you for giving me your valuable time. Please visit our website for comprehensive and detailed lecture on this topic and many other topics. Our website addresses are there. Thank you. Goodbye. Take care. We'll meet in some other video.